Hey guys, so today we're going to be looking at percent composition. We're going to do this first by talking about what is the idea of percent composition, kind of some background on it. And finally, I'm going to show you guys how to do it yourself, and you're going to do some practice problems on your own. So in general, percent composition is essentially saying how much mass of a compound is made up by a single element. The way we can solve for this is we take the total mass of all atoms of that element in the compound and divide by the total molar mass of the compound itself. That gives us a decimal, and then what we need to do to get a percentage is we multiply by 100. So that's going to give us our percent by mass. All right, let's do an example problem. Now in this example problem, we're going to look to find the percent of hydrogen in water. So what we're going to do first is we're going to write out our general formula for percent composition. Now the mass of hydrogen, each hydrogen atom is 1.01 grams per mole. Because there's 2 in the compound, we need to multiply that by 2. And we're going to divide by the molar mass of water, which is 18 grams per mole. We cannot forget to multiply by 100 because, again, we're getting it into percent. If we solve this out, we get an answer of 11.2%, which means that in a water molecule, 11.2% of the mass comes from the hydrogen atoms. In this problem, I want to find the percent composition of nitrogen in ammonium sulfate. So here we have our compound ammonium sulfate, and we're looking for what is essentially the percent by mass of nitrogen in this compound. The first thing we need to do is we need to figure out what is the molar mass of nitrogen alone in this compound. The way we're going to do that is we're going to count the total number of atoms of nitrogen, which is 2, and then we're going to divide the mass of those 2 nitrogen atoms by the total mass of the compound. So here's what we're going to do. First, we're going to write out our general formula. The mass of nitrogen, we said there's 2 of them, and each nitrogen weighs 14.01. And the mass of the total compound is 132.14 grams per mole. Can't forget to multiply by 100 because this is going to need to be a percentage. And if you do the math out, 28.02 divided by 132.14 gives us 21.20%. For sig fig purposes, there's going to be 4, so it's 21.20%. 21.20% of nitrogen in ammonium sulfate. Okay. Now let's do another example problem. I want you to now find, instead of just the percent composition of one element in a compound, I want you to find the percent composition of each element within this compound, lead carbonate. All right, so this is lead 2 carbonate, which means it's just PbCO3. So take a second, pause the video, solve the problem. If you get stuck or get your answer, unpause the video, and we'll work through it together. All right, now that you've had a few seconds to try it on your own, let's solve it together. First element we're going to look at is lead. We're going to write out the general form of our percent composition equation, and it's going to be the mass of lead over the mass of the compound. The mass of lead is 207.2 grams per mole. And in our compound, there's only 1 atom of lead for every molecule of the compound. The molar mass of the compound is going to be 267.2 grams per mole. We multiply by 100 to get the fact that lead is 77.54% by mass in this compound. Now we're going to do the same thing for carbon and oxygen. Okay, now that we've solved for each of these, check them against your numbers. We have 77.54% lead, 4.495% carbon, and 17.96% oxygen. You add these three together and you'll find that it equals very close to 100%, and that's our target here. All right, now before we get into finding percent composition of hydrates, let's first talk about what is a hydrate in the first place. Hydrates are going to be chemical compounds which are in their solid form associated with water molecules. Now the way we are going to name these is going to be based off of simply naming the compound. Normally these are ionic compounds, and as such we're going to utilize our standard ionic naming system, talked about in a prior video. We're then going to state the number of water molecules it's associated with utilizing our Greek prefix system. So for example here, copper sulfate, you can see that it is copper sulfate and then the dot product with 5 water molecules. Now the dot means that we're not actually physically bound to the water molecules, it's just associated through these intermolecular forces. So the way we state this is it's going to be copper sulfate pentahydrate. Copper sulfate because that's the name of our compound, pentahydrate because there are 5 water molecules associated with each copper sulfate formula unit. So with hydrates, one of the most important things that we're going to look at is the percent of water within a hydrate. So what we're going to do with this is we're going to utilize the mass of the water found in the hydrate and divide by the total molar mass of the hydrate. Again, for any percent composition, we're going to multiply by 100 to get us to our final answer. All right, now let's do an example problem together where we find the percentage of water within a hydrate. This hydrate is magnesium sulfate heptahydrate. Right? Heptahydrate means that there's 7 water molecules associated with every magnesium sulfate. So what we need to do is, again, we're going to use our same general format for the percent composition. I'm looking for the percent composition of water. So instead of a single element, now I'm looking for the molecule water. So what we're going to do is the mass of water over the mass of our hydrate. Now, there are 7 water molecules, each which weighs 18 grams per mole. So what we're going to do is multiply 7 times 18. And we're going to divide that by the mass of the hydrate. Now, when we look at the mass of the hydrate, that's the entire compound, both the magnesium sulfate and the 7 water molecules. So that gives us a total molar mass of the hydrate of 246.5 grams per mole. Now, we solve this out and we find that we have 51.17 or 51.2% water. This means that of this entire hydrate, 51.2% of the mass is in the form of the water molecules associated with the hydrate. All right, now I want you guys to try one on your own. I want you to find the percentage of water in copper sulfate pentahydrate. So this is copper sulfate associated with 5 water molecules. So find the percentage of water. I need you guys to pause the video, take a few seconds to solve it. All right, when you get an answer, get stuck, unpause the video, and we'll work through it together. All right, now that you've had a few seconds to solve it, let's look through it together. Again, we're going to write our general formula first. There are 5 water molecules, so we're going to have to multiply 5 times 18, which gives us a number of 90 grams per mole of water. That divided by the total mass of our hydrate compound, which is 249.7 grams per mole, multiplied by 100, gives us our percentage of water of 36.08 or 36.1% water. So within this compound, in the hydrate form, 36.1% of the mass is comprised of simply water molecules. All right, so a few things to remember for percent composition before we wrap up. Number 1 is that percent composition is measured as a unit of percent. So this means you have to make sure that when you're doing it, you're either multiplying by 100, or when you're solving from it, you're dividing by 100 to do it. Second thing is percent composition is always based on mass of your substance. And finally, we have to remember that the stoichiometric ratios are not just based off of coefficients, but it's the subscripts that matter for percent composition. So you have to account for the number of atoms in a compound. All right, so the coefficients are about the number of molecules, not the composition of the molecules. All right, guys, so that wraps up today's video. Today we discussed what is percent composition, and then we went through both percent composition of compounds and the percent composition of hydrates. Now, I'd like to thank Enam Oscar Phoenix for writing, filming, and editing this video. I'd like to thank you guys for watching it, and I'll see you in the next one.